When you use a numerical method to approximate the solution of an ODE, we introduce errors at each step. A good quality which is desirable for any numerical method is that a small error in the initial condition will produce small changes in the final result. So I'll go on and look at the growth of error after n steps. If we denote the growth of error after n steps by an, if the absolute value of this growth of error is approximately equals to n multiplied by c, where c is a constant, then we have a linear growth of the error. And if the absolute value of the growth of the error is approximately equals to k to the power n multiplied by c, where c is a constant, and then the growth of the error there will be exponential. But it will be dependent now on the value of the k that we have here. If k is greater than 1, then we would have exponential growth as n approaches infinity. Because if n is greater than 1 and n is approaching infinity, then the growth of the error there will be of an exponential form. And if k is between 0 and 1, if you still recall, if you have a number like 1 over 2 and you raise it to a power, when you increase the power, the value will get smaller and smaller. So if k is between 0 and 1 and we are raising it to a power n, then we would have exponential decay as n approaches infinity. The growth in error will be decreasing. So I'll now go on and illustrate some error sequences graphically. So we can have a stable decreasing error. The error decreases, then goes on to a stable value. So I can just illustrate this by drawing my horizontal axis where we have the n, and the vertical axis we have the error there. So we'll be having the error will be coming down and approaches a stable value. So we have stable decreasing error, or we can just have a stable error. So to illustrate this, I'll plot a graph there and draw my horizontal axis where we have the n, the iterations, and then now we go on and plot the error there in the vertical axis. So we can have the error at first starts to grow, but then levels up to a certain value. So what we'll be having here, this is an illustration of a stable error is stabilizing at a certain value there. Or the other option, we can have unstable increasing error. So to illustrate this, I'll plot my horizontal axis where you have the n, a number of iterations, then the error. So I will label the error there and the vertical axis, and we'll be having the error there just keeps on going up, up. It's increasing, unstable increasing error. It's not stabilizing to any value whatsoever. So this is just an illustration of some types of error sequences that we can have.